We have been tremendously sponsored and supported by Alberta Tomorrow. We collaborate extensively with them and back and forth sharing of ideas and resources. And they're a tremendous support, and they're connected to ALSI. So the tool itself is a scaled down version of a professional model. So for example, in our technical document, you'll see that the modeling that's done with all the data that we have goes through ALSI's and then is exported to BC Tomorrow. So our version is a scaled down version. So we have a lot of support from these two organizations. Financially, the Real Estate Foundation has been tremendous for us, as has the Investment Agriculture Foundation. And from the start, through 1% for the Planet. So we've been at this since 2014. And from the very beginning, CE Analytic and Integral Ecology Group have been there with us every year. Lately, we've been also had a tremendous amount of support from the RBC Foundation. TELUS, Marathon Surfaces, and Van City have been strong supporters, and we're just developing a relationship with Aero Trucking and Aero Service. Our local Shuswap Community Foundation and our local Rotary clubs have been also extremely supportive. And so our support is wide. We have lots of different supporters in the community. And I'm going to go through our mission again. We're helping students and teachers explore sustainability when considering land use decisions in BC. So we look at land use, so getting on the land and comparing what we do to the benefits that we get from the land and what are the liabilities and what does that look like long term. So that's our basic mission. I've probably showed you where we came from. I wrote my master's on watershed sustainability, and Barry Wilson saw an article in the paper, and the two of us decided to create BC Tomorrow. We, like I was saying, are supported tremendously by Alberta Tomorrow. The originators, the founders of this program are Matt Carlson and Dr. Brad Stelfox of the ALSI's group. And what we see in here is real data derived from the published literature and reviewed by leading scientists. So it's all real stuff. Now, today, our focus is on quests. So what I have and what everybody gets if they sign into one of our webinars is they get a how-to checklist. And so the checklist itself is just meant to be kind of a getting started cheat sheet. How to get into the simulator, create an account, locate the main dashboard. Have you run simulations? So I'm not going to necessarily spend a bunch of time on simulations right now. Here, number five is where the ready to use templates are. And so there's templates designed for elementary, grade 9 science. So it's called In the Balance. It's systems thinking. And then there's earth and environmental science for watersheds and sustainability. Those templates are there. And like I was saying, I'm going to make these water quality testing ones. There's the scenario part, number 6. Down here at the other features are some of the extra things on our dashboard. And I'm specifically going to talk here about quests and how they look. So on the main dashboard, there is the scrolling different things that you can go through. Here's all the scenarios. I've got one that's for however long I've been running these webinars for a while, and this one I can't get rid of this guy. So the rest of my scenarios are there, and then down near the bottom I've got where students. So right now I don't have a class, so I don't have any students. But when students sign on, they select me as their teacher, and here is where I can track them and keep track of their points and what they've emailed, etc. And so the teacher resources, okay. So lesson templates are all here. So for science teachers, there's the In the Balance. You were talking about governing. So decision making, governments have it rough. This is a lesson template that is all about decision making. So it's really good for social studies. And the point of this Science 9 lesson that's in the balance is um, you learn about systems thinking and looking at things from the big perspective as a system and how the different parts interconnect. This one here is, how do you prioritize decision making? And so you could, student in the simulator, students will look at the different indicators and how they change. And one particular student might see water quality as their priority and GDP as their priority and water conservation, while another student might see natural habitats as their priority and fish habitat and agriculture production. And all the students are going to have different perspectives. And the point of this lesson is, how do we come and arrive at a consensus where we can all focus our energies? So there's two templates available. Mission Explorer, the videos are all there, teacher resources. So the tutorials, I'm going to load a Quest tutorial here shortly so that people can see how to do it.
May I ask a question?
Sure.
When you just show me this, you showed this to us last time too.
Mhm.
But when I look at this, I think, why on earth hasn't the province adopted this?
Because I don't think anybody's ever done it before. And it's been part of one of the challenges has been this is a different perspective. It's like our curriculum has gone through a big redesign, and it's much more. Here, I'm going to show you a slide. So
Okay.
it might be easier to explain it this way. On this slide, you might remember looking at, so here what happens in schools is it's kind of a block by block system. So I might learn about our natural environment a little bit in geology and neurosciences, or as we were talking earlier, in chemistry or biology. Then I might over here learn about the politics and economics of the same area, but at some time later. So I'm in the geography and social studies block, and then I go over to this block and I learn about, I'm in a different block. And so
Right.
the block by block kind of sectors, it kind of splits things apart. What our curriculum has gone through is a redesign where it's much more holistic. And so our learning tool fits really, really well with the new redesigned curriculum and how it's integrates what you do and looking at different subjects from different perspectives. And it's all about competencies and coming at things from this big ideas perspective. So it's really good. And so why the province hasn't adopted? Well, it could be that we end up talking to the province and working together at some point.
Well, one a little bit further exploration of that. No, go back to the graph you showed us a moment ago.
This one?
No, they understand the know and the do.
Okay.
When you describe that, is that something you are creating or the province has implemented?
Yeah, this is a school, like a Ministry of Education document.
Okay.
So
which is a step forward from the one in the back, but
yep.
They haven't yet gotten around to recognizing the possibilities of using the whole process of that BC Tomorrow has. Is that correct?
Yeah, I guess we just launched here, like our version just came online in March. So
Okay.
we're really new still.
I got it. Thank you very much.
Okay. And so the videos are all there, and these are learning resources in themselves, and they're you can run lessons off these. And so, for example, water quality, there's the water quality lesson or video that would match.
Human land use activities influence the movement of water through watersheds in many ways.
And it would show, the video itself would show and align well with a lesson that's on water quality, as would the watersheds video or the ecological goods and services video. And the video series themselves are designed for educators, where they have graphics and text that students can refer to. There's pauses in the videos. and the videos themselves will discuss the different sector benefits and liabilities, and then emphasize this holistic approach, being that in all things, it's important to consider the benefits and the liabilities and come up with a balance. So the video series itself works that way. The scenario part, the simulator, this is where you design your scenarios. And so people can go back 100 years and see the landscapes change, how the landscape has changed. They can scroll into the future and look 30 years into the future. And the reason we chose 30 years is because in a student's, that's when most students are going to be adults. So it's in their lifetime. So you look at the future, and then this one here is the applied tool, where students get a chance to design their own plan. They don't have to. There's lots and lots in this tool that can be part of a lesson or be part of a unit. And as students progress through school, they might come back to this at different times and at different parts with higher degrees of sophistication. I could show you this slide here. The way the tool itself is designed is we can build understanding. So you can use it a little bit when they're young, and you can use it with increasing levels of sophistication as they get to higher and higher levels. And what I found was when students came back to it again, they had different perspectives and they were able to apply their learning much better. And when they finished with it, they're going to take it with them into their careers, their community engagement, potentially the entrepreneurial side, the whole green economy, and potentially their post-secondary choices. So there's lots there. Observations. Oh, I better leave one. I'm going to leave that. Now here's where we can start to get into some of the observations. I'm going to briefly go through how to do an observation, and this is where water quality testing would work. So what you do is I'm going to go into Surrey. Now I'll apologize. I don't know exactly where the stream is, but you can zoom right in, and I'm just going to probably choose a stream. You can zoom right in to where the stream is. Is that somewhat?
That's Twin Timbers Forest.
Is that somewhat close? Can I just use this as an example then? Would that be okay?
You can use it, yeah, but we are way like on the west,
Okay, so a bit more over
the
here.
left of it.
Yeah.
So if you go all the way down, yeah, just choose any stream and it will be fine.
Okay, so I'll go back to that. Okay, so with an observation, so this is an observation. I'm going to make an observation. Let's say we do water quality testing in this little, looks like a pond. Okay, I'll go right here. Now, click on the spot. So choose your spot, find your spot, and then this is the choices we have are water quality or land use. So what I see here, it looks to me like there's a field. This might be, oh, it's a picnic park. So it's a park. So the land use would be a park, and a description would be a lake and surrounded by forest. And so a brief, depending on if it's grade 11 or 12 students, so they would put a title, a brief description of the area, and then, oh, I better call this is called Timbers Park. And the description, it's a lake surrounded by urban development. And now a description of the ecosystem. So what are we looking at? We could be looking at a wetland. We could be looking at an aquatic environment. So we'll put a brief description about what the ecosystem is. And so students can do this on their own. Human activity. What kind of human activity do we have here? We have walking trails. We have some small roads. We have picnic tables, nearby parking lot. This little lake may be influenced by this parking lot over on this side. Are there other things to this? Looks like a school. Nope. And so some reflections on human activity, the weather, And then here is where they can take a recording, like a video or a media file of some kind, and upload it as part of their observation, and that will stay there, and you can come back and look at it in your class. So that's a land use observation. I'm gonna go back. A water quality observation would be very similar, except it's going to be, oh, this looks like somebody's done one. That's me. A water quality observation would have the same thing. So timber forest, give it a title. The description, it's an urban lake environment surrounded by residential development or industry or whatever it is. Now here, so depending on the level of sophistication, we can use our data, phosphates, nitrates, temperature, dissolved oxygen. You don't have to do them all. So for younger students, there's can do pH, maybe turbidity. You can use the what's the turbidity meter called again? You could look at how clear the water is, dissolved oxygen, and temperature. Simple ones. For higher level students, there's some more chemistry in there. And the same thing, drag and drop media files, and that data will be saved year after year. So observations can be connected, and then you can bring those back, put them on the projector in class, have a discussion about what it is that the water quality is. As we have more people putting observations in there, what's going to be interesting is somebody can do an urban observation like that, and then the discussion can go to somebody else's observation that's higher up the watershed, and look at the data and say, well, why is it different? What is it about if someone's put an observation in this area, or out here on the coast, or in a different area that's higher up? There would be an interesting discussion about comparing the data from here to the data from here. And so before I go any farther, that's a basic run through of how the observations are recorded on the simulator. The templates that I'm going to make will kind of guide through that process and provide, work that the students can carry with them, or the teacher can use to kind of guide the lesson. But that's the basic principle of how our simulator records and tracks the information. And so before I go into the quests, now how does that, is there any questions about how that goes? No? The reporting templates. The reporting templates are for people to export and share. And they're directed or designed primarily to use with the scenario. So when a person is going to, or a teacher has their students work through parts of the simulator by adding the different, so just down here, you use this middle button here. I did a future of the Shuswap. So I did the business as usual of the Shuswap. And then I did a historic scenario. So I can include both of those. You can include up to 4 scenarios on your report, then launch. And what the simulator will do, or what our tool will do, is compare them. And so as a teachable moment, the students have made this work, and they've gone through and they've worked through this. And there's an awful lot of data here. There's the colors that are on the simulator. So the agriculture, the grass, the water, the wetland, the settlement. So how did these colors change through time? So you can see the trends. There's the graph, the trends, and you can see here the trends in this scenario. there's also the data that's just shows the trends in the indicators, so the environmental indicators and the socioeconomic indicators. So you'll be able to compare both. What I'm not going to talk a whole lot about right now is how to deal with these beneficial management practices. Once there's a part in the simulator where you can turn these on or turn these off. They're good and they're really helpful because they have a big impact. But what's interesting is down at the bottom here, students can give their title or their report a title. They can describe what they tried to do or what they saw, and then they can give some analysis. So some reflection, answer some questions, give some feedback about what they thought, save it, and then they can share it by, they can email it, they can share it or share it in social media. I'll just do this one quickly. Demo demonstration. And what are we looking at? We are looking at example, and I reflected on water quality and urban in urban setting. So we save, and then we share. And that's there where the students can email, share to Facebook, Pinterest, Twitter. And that, if I choose that, I can email this to my teacher or to whoever I'm wanting to share with. So that's the sharing and the report builder. And now to the quests. So down here on the dashboard, and these are they're designed for students to extend their learning. So down here on the dashboard in the achievement section are the quests. And so some of these, okay, here, let's look at this. Here's a decision-making quest. So it says a steward, so it's watershed stewardship and how do you make decisions? And so a steward of the watershed means helping to responsibly balance human and economic needs. This looks interesting. So I would open the quest and view some details. And so this little icon shows that the quest is open and it describes the stewardship of a watershed, balancing human needs with the needs of who, it says here, who and how are decisions made regarding land use activities. I'm interested in that quest. And so what do I have to do to get these points? I have to run a historic and business as usual scenario. So if I accept this quest, what's going to happen is this little quest icon will show up there. And I want to keep going on this quest and do the activity. So now I've looks like to me, while the quest was open, I ran the historic and the business as usual scenario, and I just made a note of concerning trends. And so when the quest icon appears up here, I run the historic scenario. So I can go back to the dashboard and I can run the scenario and the simulator. So I've still got this icon up here and I can do what I'm supposed to do. If I forget, I can go back. Cancel there. If I forget, I can go back. There we go. It's going a bit slow. Usually you can have this open at the same time. If I forget, I can go back to see what I'm supposed to do. So as long as this icon is open, then and I run this scenario and I run this scenario, the simulator will automatically track when I'm done. It ticks it off for me. And then it says I'm supposed to develop a land use plan and make adjustments to the management settings until I've balanced the solution and title my plan BC Watershed Decisions. So I have to make a plan myself and put that title, not the quotations, just the title. And the simulator, when I do that, the simulator will check it off for me. And then it says I have to create a report in the description and justify why or how you plan to address concerns. So there's the report reference, and students have a chance to share some of the learning while they describe. And so what the simulator is going to do, as long as this icon's open, the simulator is going to track as you work through this quest. and I can close it and come back to it
Now-
later. So,
Now, this is the individual student is doing this.
yeah.
I'm sorry.
So the achievement, so that student then is going to work away at this quest, and
All right.
this one's in motion. I started this one, and I'm working on it. Or I could do this watershed stewardship community involvement. So here's being a caretaker of their watershed. They can get involved in a community restoration project of some kind. Oh, that looks interesting. So what do I have to do? I have to watch the video. So while the icon is open, I watch this video, I watch this video, then I develop a plan that has that exact title in it, not the quotations. And then I create a land use observation. So I'm supposed to go out into the community, and it says I have to create a land use observation by taking a picture of the project I was involved in. And then I upload the photo with the watershed steward, that title, on my observation. And if I do it, all these little things will be checked off. And as soon as I'm done, I'll get a bunch of extra points. So looks like here, I'm going to show you one that I just did called I'm a Water Guardian. So I did this quest down here called Healthy versus Eutrophic Streams. So here's a water quality testing. So let's see what I had to do. I had to watch the watersheds video and learn more about watersheds. Then I had to watch the fish habitats video to see what healthy and eutrophic streams look like. Then I had to create a poster and comparing healthy to eutrophic streams. So there's some work in a classroom. Now I've learned a fair bit. And then it says, then I use the satellite imagery to create a system observation. So I'm going to go and see what that looks like. So I've completed this quest. I should be able to find it. So here's the quest. And there it is. I want to see what I did. Aha. So I did it in this area down here really close to our school. So this is Little Salmon Arm. I watched the videos and I created a project, and I went out into the field. So here's our school right here. And I walked through down the road and into this little stream, very similar to the one we saw in Surrey there, where there's urban and residential development near a stream. And I took what did I do? I described the ecosystem. So I said it was a little bit about the creek, and it's an urban forest. The ecosystem, etc., is dominated by the different tree species. Then I said a little bit about the human activity in the area. I talked about the weather conditions. Here's where the title goes. So I'm always asked in an observation to put a title in there, and you just have to match exactly what it says in the quest. And then I took an image, and so what I see here is and I did this on purpose. This project to the left is a fairly sophisticated grade 11/12 earth science project, or earth science and biology project. And so I did a fair bit of work learning about streams, and I went out and made an analysis of this stream, and I would reflect on what does this stream look like compared to my theoretical. This project on the right is from a grade 4 student who did a watershed project, and these quests are applicable to students of younger. And the reason I put both these projects in here was because these quests and these projects are suitable for students of younger ages and of older ages. So everybody can get quite a bit of learning out of the different quests as they apply it to their local environment. So that's a little bit about the quests. And so for the types we have right now are watershed stewardship. So that's a decision making. So that would be a governing one. This would be a community involvement. So getting into a volunteer project of some kind with an organization. This one here is about the invasive species. It's quite often It's a topic in our curriculum, and it's also a topic that comes up in the news a lot. And healthy food. There's a big conversation recently, especially during the pandemic, food security. So there's a quest about food security. Fish habitat. This is the wanted alive one. Fish and water quality are closely related. So we want to find in this quest, what are we supposed to do? Watch the water quality, fish habitat, make a land use plan that's titled Wanted Alive. So we're trying to find habitat. And then it says I'm supposed to make a poster of native fish in BC and include that in my project. Very similar to the one I just did. So that's an interesting one. Myth of abundance. We talk about, oh, we got tons of fresh water. We're never going to run out of it. Maybe. That's an interesting project. Talks about the flushing rate of lakes. It's a big deal in the interior. Here's the streams one that I went on. Sustainable forestry and forest sustained. It's a big topic in British Columbia. In fact, I've been learning a lot about this while I've been doing this presentation series. That's an interesting quest. Mining for our future. Mining makes a significant contribution to BC's GDP. It's a big industry. So there's an interesting quest there. And then something really, one of the real important competencies in our curriculum is critical thinking. And our simulator has all this data and all this modeling, and something students can do on a quest is go and check some of those assumptions. And what does it ask them to do? It asks them to watch the human population video and the human settlement video, develop a future land use plan, and then they're supposed to look at the assumptions in the technical document. So what we have is a reference document in the simulator that shows where all our data came from and how the assumptions are made. So this gives the students a chance to reflect on the data itself, and are these assumptions valid? So that's an interesting one, and we'll have many more quests as we work with more and more teachers. And so before I go into the simulator, is there any questions about how those quests function or how I did it? Or the key is to open it. Oops, open it and have the little icon up here as you're working on, so that the simulator can track the tasks that have been done. And actually I struggled a bit when I was doing my example. I actually put quotations in the title. And that prevented the simulator from recognizing it. So I'm going to have to make sure that people don't put the quotations in the title. So does that make sense?
Yes.
Okay. A little bit about the scenarios now. I'm just conscious of the time. So our scenario simulator allows 3 choices, and a student or a class or a group of students, they don't have to do all 3. They can just do the historic, or they can just do the future, or they could just do their own. Typically though, we go back in time first to see what the land looked like 100 years ago. So historic, we're going to choose our watershed. So we're going to go into the lower Fraser Valley here. Oops, that's the lower Fraser. That's a big one. If you wanted to stop there, you could hit next and run a scenario for the whole lower Fraser. That would be interesting. You can see where the urban and rural development and how the changes work. Or we can zoom in just on the lower Fraser on the coast and do a smaller one. So we're looking at the lower mainland historic, and we want to look back and see how the landscape has changed. Something for prep for teachers, should say on the cheat sheet, is anytime the first scenario has been run. So if once the simulator has run one scenario in a watershed, it caches the data so that everybody accesses, and it goes much faster. So this is a map. In the map function, we can choose streets, the street view, or satellite view. I tend to like the satellite view. It gives quite a bit more contrast. Something also that's kind of interesting is we can show observations that people have done. So we did that observation during our quest, or we can turn them off, and so that observations aren't visible. You can also turn this data layer on and off, and what'll happen if you turn this data layer off, I can go through that in a minute. The indicators will change, but you won't see any color changes on the landscape. You can just look at the actual landscape and try to discuss how is it that the land is changing. Anyways, those are extra things. So what we're seeing here is the Lower Mainland as it looked according to these land type classifications. So back in 1910, this region, about this much area, was agriculture. So with every landscape and with every indicator, there's a description and a link to a video. So you can learn about, and actually there's also this, once we start playing the simulator, you'll be able to see this graph change as time goes on. So up and down and up and down. And what are we seeing? Number of hectares of agriculture in this region change. So the colors should match the graph. So if I go back, red is agriculture, and it's going down. The agriculture area is going down, the hectares, and lo and behold, we see the purple, it looks like, covering up the red. So we're seeing a change in agriculture. Now we can see that happening. We can see lots of changes in BC, or in the Lower Mainland. And what are we looking at? Yellow is grass, blue is water, so that's surface water, so lakes and streams, nothing to do with underground. Wetlands, so light green, so there's wetland, there's wetlands. Out here in Burns Bog, some significant wetland areas. Forests, so darker green is the forest. Purple is urban settlement, and gray is industry, so we should see like malls and airports and bigger industry like that. And white is alpine. So there's a description with everyone and a graph. And then up here are the indicators, and the same thing happens. So we have the environmental indicators and the socioeconomic. Our intent is to provide a balanced perspective. And so what are we seeing here? We see back in the early 1900s, the values of the environmental indicators were quite high. We didn't have many greenhouse gases, and the socioeconomic indicators were quite low. However, as things change, the indicators change. So as agriculture goes down, for example, number of people fed would go down. Or as timber production goes up, GDP goes up. Or as human population goes up, grizzly bear habitat goes down. There's lots and lots of relationships happening on the land. And so we're seeing all kinds of changes on the landscape. And these indicators, so this is an indication of the environmental health and the socioeconomic performance of the area. And so the historic scenario is really good to see how things have changed. So is there, before I go any farther, is there any questions about the historic scenario? It's a really interesting way to look and see how the landscape was and how much it's changed up to today. This chart here shows the number of hectares in this watershed in 1910 and the number of hectares of agriculture, and it's gone down by 10,000 hectares. Grasslands, We don't have an accurate measure, or there's none left. It's gone down by number of hectares. We can see urban settlement was occupied in 1910 was that much area, and it's gone up by quite a bit. So this shows is a summary, like a number of hectares summary. Okay, so that's the go back in time part. And then the next step is into the future. So what's it going to look like potentially in the future? Oops. So we're going to that same area. And what are we going to see here? Business as usual. Future. We're going to look into the future given current trends. So what our simulator does is it takes the last 30 years, trends over the last 30 years, and moves them into the future. Our next big piece that we're going to add to this is we're going to be able to incorporate climate change as part of as a choice that students could make. They could ignore it, or they can choose one of the options and see and see what the potential impacts are on the indicators. But right now we're not quite there yet. So the future scenario, sorry.
Well, just one small question. When you talk about, you take the last 30 years and project it forward, is straight line projection, or are you actually fitting a curve? And
Yep, probably, yeah, I'd have to look at the assumptions exactly to quote exactly, but okay, let me just make a quick reference to that. Every single indicator and every single landscape type, so I didn't show that too well. At the bottom, you see this little I button. There's the technical document. So how the modeling has been done and how all the assumptions are made is in the technical document, and you can access it with the I button at every single indicator. So you'll see it down at the bottom there, right, like that. Okay, so that's where you find it.
I see. Great.
So now what are we seeing? Okay, we're seeing not a lot of fish habitat, not a lot of grizzly habitat. Human population is at 50%, and water consumption. And what are the trends for the future now? Looks like greenhouse gas emissions are going up. The trend is, and natural landscapes. Oh, what do we have here? We have a little quiz. This is a little challenge here. It says BC's diverse landscape and climate conditions allow for the production of over 200 agricultural commodities like fruits, vegetables, grains, ornamental plants, livestock. Why was the agricultural land reserve created? Well, farming and forestry were competing for the same land. Valuable farmland was being lost to human settlement. So that's interesting. I would have said that one.
Right.
See. Yes. Little teachable moments.
Right. I do have a question. How did you happen to choose swimming pools as an indicator?
Something that kids could relate to.
Right.
So what do we have here? So this is showing the trends into the future and water consumption. And so at this point, so when we look back in time, there might be an opportunity. We're talking about the government. So here, let's have a look here. The students will look at these indicators, and some students might be really concerned about this set and a little bit concerned about these, while other students might be really concerned about this set and just a little about these. And so one of the things about governing is they have it rough. They got to please all the people all the time, and people have different values. How is it that we can arrive at a consensus? And so one of the exercises kind of goes through that process with the kids and asks them to prioritize their top 4. What are the top 4 that they want to address in their plan? So they'll see the future go, they'll watch they'll look back 100 years and then they go into the future, and one student might choose fish habitat, bear habitat, human or GDP, and human population as their 4 top priorities. Somebody else might choose greenhouse gas emissions, timber production, agricultural production, and stored carbon. The point is that the students then rank their top priorities, and then they discuss with each other and try to come to some kind of a consensus. And then you can do it as a whole class. What are we going to focus our energies on? What is the top priority?
Mhm.
And that way, then the potential, if they can do it, come to a consensus. Then everybody works on a plan that in a sense addresses those priorities, and that's kind of the way the lesson is designed.
Right.
So now we look at the trends, and then the last scenario. So here's where students are seeing the changes, and then they're looking at ways to adapt or to create a plan for their own future. And this is where they get to make their own plan. So now they've looked back in time, maybe they've done some field observations. Now they're going to see what they can do, create their own situation and their own plan for the future. And this step is a little different. So they're going to give it a title, My Future Plan. And I want to balance economic and environmental activities. And so now what they do is they set goals. So they see the little gray slider, so the students get a chance to set their own goals. Is this realistic to get the habitat back here? And the one thing to note is simulator only goes 30 years into the future. So in 30 years, is it realistic to gain that much bear habitat back? If that's a priority, is it realistic to get the natural landscapes back like this? So the students set their own goals, and they might have the discussion that, I want to bring grizzly bear habitat back. I better bring fish habitat back as well, because they're connected. And to get the habitats going, I better increase natural landscapes. Here we have biotic carbon, which is the carbon stored in grasses and shrubs and soils. So if I store carbon, that's going to help with my greenhouse gas emissions. That might be one of my goals. And I want to keep water quality high so the fish can survive. But I know human population looks to be increasing, so that's a potential. And I want to keep everybody making money. So okay, not a lot of mining in this area, so maybe I want to bring that along. There's forestry and timber production that contributes to GDP. Want to keep everybody fed. If population goes up, I better feed everybody. And water consumption. Okay, so this critical thinking goes on. I set goals, and the next step is to make changes on the landscape. And so here's where the students are going to select. Well, if I want water quality to go up, I better increase wetlands. And so where did we see that wetland in Surrey? I'm going to find that down here, roughly. I want to increase water quality. So if we designate this area for wetland, then that's going to help potentially. Human settlement is potentially going to grow. I'd like to have it grow in this area, and I'm going to restrict how much it grows. And I might have it grow in this area, and I'm going to restrict how much it grows. I better be careful because I want to have forests as well. So I'm going to put some forest here, and I'm going to put some forest here, and we'd like to bring some grasslands back. And what happens is the students make the plan, and then they set their goals, they make their changes, and then they, this is these practices I was talking about. These, you can turn them on or turn them off, but what I've found is it's a little easier to turn them on or off a little later on in the process. Climate change is going to be an option again. Run scenario. So how did I do relative to my goals? Those students are planning away and they're checking to see. There's no more of these quizzes coming right now, or they might pop up. Well, let's see. Here's the lights tell how I did. Let's have a look. You can watch what happens. And you can see, oh, I'm not doing too bad actually. I didn't reach, oh, it says your greenhouse gases keep increasing. What can you change in your plan? Well, how do I address greenhouse gases? They're going up. I probably want to increase my biotic carbon goal. Or increase my natural landscape so I can address greenhouse gases. That's interesting. Okay, so red means I'm not even close. Yellow, I'm not bad. Green means I reached my goal. I can go back and edit right now and add more of these pins, or I can adjust what I've done, or I can add another one. I can move these pins around. What I usually say to people is, oh, I didn't mean to do that. Sorry, folks. Just a minute. What I usually recommend at this point is, this is where you click these management practices on or off. And so watch what happens. If I click the agricultural management practice on, does it move any of the indicators? No, I see water quality changing a little bit. What happens if I move that one? I see water conservation moving a bit. Okay, that helps a little bit. Municipal water conservation. Ooh, I'm getting close now. Look at that. Just by clicking on agricultural water conservation and municipal water conservation, suddenly I'm achieving one of my goals. That's helpful. Energy sector water conservation. Does that make a difference? So the point is that after the students have made their plan, use these beneficial management practices to test, to see. And there's, like everything, there's an explanation for it right here. Urban densification, that's that going to help? That's interesting. So they can go through them all. And look at that. There's a big one. That makes a huge difference. Another one here is industrial activity. I can adjust my industrial activity slider and watch to see if any changes to the indicators happen as well. So then, so after the students have gone through their planning and tried their management practices, then I get them to go back. Then I get them to go back and edit their plan and add more pins and see how they've done. And then they can run their scenario again, and back and forth they go. And it's this process that I've noticed a huge amount of interaction between the students and a lot of back and forth, and they're testing and they're running and they're testing, and an awful lot of sharing goes on.